Hello students, welcome to physics class. In this video, we will discuss about the equations of motion by graphical method. The uniformly accelerated motion of a body is described by three equations known as equations of motion. The first equation of motion, which is also called velocity-time relation, is v is equal to u plus at. It is also called velocity-time relation since it gives a relationship between velocity and time. The second equation of motion, which is also called position-time relation, is s is equal to ut plus half at square. This equation is also known as position-time relation as it gives a relationship between position, which is denoted by s, and time taken. The third equation of motion, which is also called position velocity relation, is v square minus u square is equal to 2as. This equation is also called position velocity relation since it gives a relationship between velocity and the position of the object, which is denoted by s. In all these three equations, u is the initial velocity, a is the uniform acceleration, t is the time taken, v is final velocity, and s is the distance travelled by the object in time t. Now let's learn to derive first equation of motion by graphical method. For this, consider a velocity time graph for a body that is shown in figure. Let the body has an initial velocity u at point A, and then its velocity changes at a uniform rate from A to B in time t. In other words, there is a uniform acceleration A from A to B, and after time t, its final velocity becomes v, which is equal to bc. In the graph, the time t is represented by OC. To complete the figure, we draw the perpendicular CB from point C and draw AD parallel to OC. BE is the perpendicular from point B to OE. So, from the graph, OA is equal to CD is equal to U, since OA and CD are parallel to each other, and OE is equal to CB is equal to V, as OE and CB are parallel to each other and BC represents final velocity. And since time is represented by OC and OC is parallel to AD, therefore OC is equal to AD is equal to T. Now from the graph, since OA is the initial velocity u and BC is the final velocity v, therefore BD will be the change in velocity, which is given by BD is equal to BC minus DC. Now since BC is the final velocity and DC is equal to OA, as these two are parallel lines, therefore we may write in place of DC u. So BD is equal to V minus u, which is change in velocity of the object from point A to point B. Now since we have learnt that the slope of velocity time graph gives acceleration, therefore acceleration is equal to BD upon AD. So from the graph we have seen that BD is the change in velocity, which is V minus u, and from the graph you can see that AD is parallel to OC and OC is the time. Therefore in place of AD we may write T. After cross multiplication it will be AT is equal to V minus u. On simplifying it will be V is equal to u plus AT, which is the first equation of motion, where v is final velocity, u is initial velocity, a is the acceleration and t is the time taken for the change in velocity. So this is the derivation of first equation of motion by graphical method. Now we will learn to derive second equation of motion by graphical method. The second equation of motion is S is equal to ut plus half at square. So we have to derive this equation. For this, let's consider a body which is moving with initial velocity u. It covers a distance s in time t. We have learnt in velocity time graph that the distance travelled by a body is given by the area occupied below the velocity time graph. As you can see in the graph, AB is the velocity time graph. And what area comes under this velocity time graph? It is this area that comes below this VT graph AB. Now, if we darken this area that comes under this graph AB, we will find out that this is the shape of a trapezium. So, we may name it as OABC. So, here OABC is the trapezium. So, we can find out the distance travelled by the object by simply finding the area of this trapezium OABC. Now, if we make a parallel line from A to D, which is parallel to time axis OC, we will see that this trapezium OABC is divided into two figures. One is the triangle, that is ABD, and other one is the rectangle, which is OADC. So now this trapezium is divided into two parts, that is a triangle and a rectangle. So by finding the area of this triangle ABD and by finding the area of this rectangle, we can find out the distance travelled by the object. Therefore, we may write that distance travelled by the object is given by the area that is enclosed with OABC in the graph. So, we can write that S is equal to OABC, since S is used to represent the distance travelled by the object, and OABC is divided into two figures, that is area of rectangle OADC plus area of triangle ABD. We know that the area of rectangle is side into side. OADC is the rectangle, so the area of this rectangle will be side into side. We may take any side as OC into OA. So in place of area of rectangle, we will write OA into OC. Now area of triangle ABD plus area of triangle, the formula for the triangle is, since ABD is a right angle triangle and the area of a right angle triangle is given by half base into height. Here base is the AD and height is BD. So in place of base we will write AD and in place of height we will write BD. So this will be OA into OC, which is area of rectangle, plus 1/2 AD into BD, which is the area of triangle ABD. Now substituting the values from the graph, we know that OA is the initial velocity, which is u, and OC is the time taken, which is t. Since AD is parallel to OC, therefore in place of AD also we will write t. And from first equation of motion we have learnt that BD is the change in velocity, which is equal to AT. Therefore, substituting the values in this equation, we get S is equal to UT plus 1/2. In place of AD we will write T, in place of BD we will write AT. On solving, this will be S is equal to UT plus half AT square, which is the second equation of motion, where U is initial velocity, T is time taken for change in velocity, A is acceleration, and S is the distance travelled by the object. So this is the derivation of second equation of motion by graphical method. Now we will learn to derive third equation of motion by graphical method. The third equation of motion is v square minus u square is equal to 2as. To derive this equation, we will consider an object which is moving with initial velocity u. After time t, it travels a distance s and its velocity becomes v. Now we know that the distance travelled by the object is given by the area occupied below VT graph. And the area which is occupied below this graph AB is this area, which is the area of a trapezium OABC. Therefore, by finding the area of this trapezium OABC, we can find out the distance travelled by the object. Therefore, we can write that S, which is the distance travelled by the object, is equal to the area enclosed by trapezium OABC. Now, we know that the area of trapezium is 1/2 sum of parallel sides into height. Now, as you can see from the figure, the two parallel sides of this trapezium OABC are OA and BC. Side OA and BC are the two parallel sides, and the height between these two parallel lines is OC. Therefore, on putting the values in this formula, we get distance travelled S is equal to the sum of parallel sides are OA plus BC into height is OC upon 2. Now we know that OA is the initial velocity, which is denoted by U, BC is the final velocity denoted by V, and OC is the time taken denoted by T. Now putting these values in the formula, we get S is equal to, in place of OA we will write U, in place of BC we will write V, in place of OC we will write T. So it is U plus V into T upon 2. Now we will substitute the value of T from first equation of motion, which is V is equal to U plus AT. From this equation we will substitute the value of T, V minus U upon A. The value of T we will put in this equation. On putting this value of T in this equation, we get S is equal to U plus V upon 2 multiplied by V minus U upon A. Now we know the algebraic identity, which is A plus B, A minus B is equal to A square minus B square. Therefore, in place of V plus U, V minus U, we will write V square minus U square. So, on cross multiplication, it will be V square minus U square is equal to 2AS, which is third equation of motion, where V is final velocity, U is initial velocity, A is acceleration, and S is the distance travelled by the object. So, this is the derivation of third equation of motion by graphical method. So, this is all about equations of motion by graphical method. Thank you. See you in the next video.